All right, now transformations of these sine and cosine graphs. Now we did amplitude, frequency, period. We focused really on amplitude and period in lesson 48. Now we are moving into transformations, and that is going to encompass everything, amplitude, period, but also horizontal and vertical shifts. So we're going to be shifting left and right, shifting up and down. Really what this lesson is going to do is we're going to actually be graphing shifts up and down. It's tricky to graph the phase shifts, and I don't think you're going to have to do that. So we're going to be doing a lot of graphing with phase shifts. You'll see it as we get better at these. I'll throw a couple in there at you just to kind of give you an idea, a little taste of it, in case they do throw that on the Regents exam at you. But really in this lesson, we're going to focus on those vertical shifts up and down. We are going to talk about phase shifts. So phase shift is a horizontal shift. So this is all review here. Recall, right? The general form, A sine W x minus H plus K. And then the same thing for cos. All right. Amplitude is the A. All right, that's the formula for amplitude. We did that in the last lesson. Formula for period is 2 pi divided by W. Okay, so period is 2 pi divided by W, and frequency is just the flip of that. All right, so now today we're going to learn 2 more types of transformations, horizontal and vertical shifts, like I said. So now we're going to start with the vertical shift, which is also known as the midline of the graph, because we talked about how, if you have just regular, for example, regular sine, okay, regular sine does this, sine x, just plain old sine x with nothing else, does that, right? And it goes to 2 pi. That's what plain old y equals sine x does. Well, if there is no shift up and down, the midline of the graph, the middle line, is this right here, and that is the x-axis, and that is the line y equals 0. So if there's no shift at all, there's no vertical shift, that will be, it's like having a plus 0. That's like the k being a 0. So when you see just, for example, y equals 2 sine x, like we did the other day, right? Okay, it's really plus 0. So there is no shift. The midline or shift is 0. Well, now we're going to change that number. We're going to change that k value. Okay? The phase shift is the horizontal shift. That's what moves the graph left and right. And that comes after the x. That's that h value. I didn't want to cross that off. That's that h value right there. The h is the phase shift, and it's the opposite direction. So it's very similar to, remember, parabolas? Okay, vertex form, y equals, I'm going to show you how this is very similar. Y equals x minus h squared plus k. Remember those? Those give you parabolas, and that's the vertex form. And say it was y equals x minus 3 squared plus 5, right? The vertex would be 3, 5. Remember that? You would change this, well, not change the sign, you're just taking the h value, right? Which is the opposite of what you see here, because it's minus h. So the h value is 3, the k is just 5. So it's very similar to that, in that you have to make sure when you're doing h, because it's minus h, the standard form is x minus h, you have to change that sign of the h, of whatever you see. So for our phase shifts, it's going to be the opposite of what you see. I don't want to confuse you with that, but I think that's a similar thing there. So here we go. I gave you example 1. There's 3 functions here, and amplitude period we should already know. Amplitude is going to be 2, right? Amplitude is going to be 3. Amplitude is going to be 4. All right, pretty easy. The period is 2 pi. Remember period? Period is 2 pi over w. 2 pi over w, absolute value of w, actually. All right, and 2 pi over 3 here. 2 pi over 3. And this one's going to be 2 pi over 4, which reduces down to pi over 2. And this one's going to be 2 pi over a half, which goes to 4 pi. And we did a bunch of those the other day. All right, now, your frequency is the flip of the period. We did this as well. So this is 3 over 2 pi. This is 2 over pi. This is a pi. And this is 1 over 4 pi. All right? And then the midline the midline is this number. Okay, and that is the vertical shift. That's what's moving the graph up and down. We're going to be doing the graphs of those in just a minute. Okay, and our phase shift is what comes after. That's the horizontal shift. You might want to put, this is the vertical, this is the vertical, and this is the horizontal shift. So the midline is the vertical shift, the phase shift is the horizontal shift. And that is right here. See how it's pi over 2? It comes x minus pi over 2. So that's a pi over 2 phase shift. That means it's going to move to the right, not to the left. All right, pi over 6. But because it's pi over 6, it's negative. It's a negative. That means it moves to the left. And this is 5 pi, but it's going to be positive 5 pi. It's going to move to the right. All right, so that's how you read the function and get your amplitude, period, frequency, horizontal shift, and vertical shift. All right, so now we're going to do a little graphing here. So how do we graph? Well, we graph by knowing a few key things. Now, you got to know, first of all, the midline. Okay, so the midline is where I start. The midline is 2. So what I'm going to do right off the bat is I'm going to go to 2. And we'll just go 1, 2, 3, 4, 5. We'll do them by ones here, right? So 2 is right here. And we're going to put a dotted line for our midline. Because no longer is the x-axis the middle of this graph. That plus 2 is going to move it up 2 units. That wave is going to move up 2 units now. So we're going to make the 2 the middle of our graph. So we're going to kind of ignore the x-axis as if it's not even there when we're actually doing our graph, our plotting our points. Okay? So now what else do we need to know? We need to know the amplitude. Well, our amplitude is 1. And that's just, again, the number in front of cos. There's nothing there, so it's a 1. All right. We know it's a cosine curve. We need to know what the regular cosine curve looks like. Because it's cos, it's going to go like this. Here, well, a normal cosine curve would do this. Okay? We got to know that. We got to know what it does. So what it does is normally starts at 1, goes to 0, goes to negative 1, goes back to 0, goes to 1. Now this won't do that. It's going to go up higher. However, it's the same pattern. See how it starts 1 above the midline? Okay? This is 1 above the midline. So we're going to start 1 above the midline right here. Okay? It's not 1 above the x-axis, it's 1 above the midline. All right? Now, how far do we go for the next point? Well, we need to know the period. That we can't go any further. That's all we can do without the period. So the period, remember, is 2 pi over w. And w is 1, because that's just the number in front of x. So this is 2 pi over 1. So the period is actually 2 pi. All right, so period is 2 pi. That means it takes 2 pi to make the full cycle. So if this was 0, this right here would be 2 pi. Now, luckily, we don't have to change that because it is 2 pi, right? Regular cos x, and this one is 2 pi. So 2 pi, we can put it wherever we want. I'm just going to go by 4s. Right? So we're going to go 1, 2, 3, 4. I'm just scaling. We're going to make that pi, and then 1, 2, 3, 4. We're going to make that 2 pi. All right, just because that's what I decided to do. You could scale it however you want to scale. This is going to be 0, obviously, right? And then we'll go 1, 2, 3, 4. We'll go 3 pi. We'll actually go up to 3 pi. It didn't tell us. We're going to go negative pi to 3 pi. I'm going to give you the interval. Negative pi to 3 pi. Boom, 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 boom. Boom, 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 boom. This is going to be negative pi here. We're going to graph all the way from negative pi to 3 pi. They usually tell you the interval, how far you got to go. But I didn't tell you that, so we're just going to do that now. All right, so let's follow the pattern. Let's do the beginning and the end. Beginning and the end. All right, so the beginning we already did. The end is at 2 pi, and that's going to be back at the top. So this is your max, right? This is the highest the graph goes. Right here is going to be your min. All right, these are important. Maxes, mins, and then the midline points. That's all you need. That's all you need. I know there's a max here. I know it's going to end at 2 pi. So I know there's a maximum point right there. And then what happens right in the middle of your max and your maxes? You got this right here, which is your min. So if you have a max and a max for a cosine curve, your min is right in between, in the middle. And my minimum is one below the midline. So that's going to go right here. Okay, I'm just following this pattern, guys. All right, one below the midline, one above the midline, one above the midline. What's in between a max and a min is going to be a midline point. So I know it's going to hit the midline right there. It's going to hit the midline right there. Because it hits the midline here, it hits the midline here. You're just copying what the cosine function does. And there it is. Now, don't connect and make a V, right? We know it's curved. We know it's curved. Oh boy, that's not that curved. And there we go. Okay, so there is from 0 to 2 pi, and then it's going to do the same thing to 4 pi. We're only going to go to 3 pi though, so we're only going to need to go back down to the minimum. We're just repeating. Oh boy. Okay, we're just repeating, and then same thing here. Just repeat it on the other side. There it is. All right, so there is the function y equals cos x plus 2. Now let's do 3 sine x minus 1. Okay, well here, okay, I have a sine graph, so I need to know what my regular sine graph does. My regular sine curve starts at 0, 0, goes up, down, and then back to zero, right? So that's what sine does. This is sine x, y equals sine x. Okay, you got to know what y equals sine x does in order to do anything else. Okay, so and I know there's a midline point right in the middle there. I know my amplitude here. Well, my midline. Let's start with my midline. I know my midline is -1. My midline is -1. I know my amplitude is 3. So I'm going to plot that. I'm going to do that midline here. It's at -1. Okay. And my amplitude's 3, so I'm going to go up 3, down 3. Because it's a sine curve, I'm going to start right on the y-axis at my midline. On the y-axis at the midline. That's what you do for a sine curve. It's not going to be 0, 0 because it's down 1, right? Down 1. That shifted the whole, that's going to shift this whole thing down 1 unit. All right, my amplitude is 3. My period is 2 pi over, it's 2 pi again because it's 2 pi over 1. 2 pi over the W, sorry. So it's just 2 pi. All right, so similar to the last one, I'm just going to go 0 here and then go boom, 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 boom. Make this pi. Boom, 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 make this 2 pi. Boom, 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 make this 3 pi. So every four boxes I made a pi. Boom, 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 boom. Pi sounds good right now, doesn't it? All right, so we have 0, 0. Now, what does the sine function do? Starts at 0, 0 and ends at 0 at the midline. Starts at the midline, ends at the midline. Got it? Okay? Starts at the midline and ends at the midline. How do I know it ends there? Because my period is 2 pi. So whatever the period says, that's where it's going to end. All right? Also, a sine graph. In the middle, it hits the midline. So that's going to be right here. I got to hit my midline. So what happens in between? It goes up to the max. Okay, so I got to go a max. Now, how high up does it go? It goes up 3 units. So right here's the middle. Boom, boom, boom. Up 3 units right there. What's going to happen between this point and this point? Right here and right here. What happens in between those? There's a minimum point. So in between this one and this one, there's a minimum. 1, 2, 3. Go down 3. See the pattern? Okay. And I'm going to connect. And there it is. There's the sine function. Boop. Okay? Midline, max, midline, min, midline. That's what the sine function does. All right? And then we're going to keep going. So we're going to go to 3 pi. At 3 pi, it's just going to go up to the max again. So it's going to go... Oh, I'm sorry. No, that's not correct. 3 pi, it's going to go back down to the midline. Your max is going to be boom, boom, boom right here. Okay. Sorry about that. There's the pattern. All right, and then same thing here. This is going to go back to the midline, and then boom, boom, boom. Just follow the pattern. Once you get one cycle, it should be easy to do more than one cycle. You just follow the pattern. We've been doing that. All right, last couple here. We're actually going to do B before we do A, okay, because B is actually a lot easier. So what we're doing now is they gave you functions here, and you're going to actually come up with the amplitude, period, midline, and then write the equation. There's 2 of them. The blue one on my screen, the blue one, this one that's shorter, like not up as high, f of x, it's labeled right here. That's right here. So the amplitude is how high it goes, right? Now, the midline is just 0, so the midline's 0 for both of these. All right, see how it goes up to 3. This one goes up to 3. This one goes up to 1. Okay, this one goes down to -1. This one goes down to -3. So because it's going 1 to -1, 3 to -3, you could tell the midline's right in, the middle of the graph is the x-axis here, okay? So it has a midline of 0. The amplitude is 1 for the f of x. It's 1 for the f of x, and it's 3 for the g of x. And then the period is the same because they're only showing you one cycle, and it stops right here at 4 pi. I don't know if you can see it on your paper, but it stops at 4 pi. So the period is 4 pi for both of these. Okay, and so that's all we really need to write the equation, although we need to know is it sine or cosine. But see how it's at 0, 0? We just did the last example. If it's at 0, 0, guys, or on the midline, at the midline in the y-axis, that is going to be a sine graph. So these are both sine. Okay, these are both sine. So what's my equation? F of x equals. Actually, I want to just thin this out real quick here a little bit. So f of x equals, now amplitude is 1, so you can put a 1 there if you want to. And then we're just going to put sine. And then we got to put wx, and then midline is 0, so plus 0. W is what we need, and that's what I'm going to practice on this example. W, remember how period is 2 pi over W? Well, if you could switch the P and the W, okay? W equals 2 pi over P, over the period. So if you know the period and you want the W, remember we did the vertex form and it was A equals 1 over 4P, P equals 1 over 4A. Same thing here. P equals 2 pi over W, W equals 2 pi over P. Okay, so if you know the period, and we do, the period's 4 pi, W is going to be 2 pi over 4 pi. Okay, and the pi's cancel, and 2 over 4 is 1/2. So W is actually 1/2, and that's why it's 1/2 x. So sine is 1/2 x. Y equals sine 1/2 x would be our function here. This one, g of x, equals, and then the amplitude's 3, so it's 3 sine 1/2 x. Again, because the period was the same. If the period's the same, the W is going to be the same for both of these. The only thing that changed between those two was the amplitude. So we have sine 1/2 x and 3 sine 1/2 x. This one's a little bit more involved because there's a midline. The midline changes. See how the midline now is, and I'm going to go to a little thicker style here. Okay, the midline here is 2. You got to locate the midline of the graph. And that's just kind of telling, well, if it goes from, this goes from the max, I'm going to do the max here. The max is 7, and the min is -3. So you got to figure out what's right in the middle of 7 and negative 3, and it's 2. Because if you're at 2, you go up 5 to get to 7, you go down 5 to get to negative 3, right? So that distance that you're going up and down from the midline is 5, and guess what? That's the amplitude. So I have a 5 amplitude. My midline we said was 2. My period is, well, let's see, here's one full cycle. One full cycle is that. So where does that stop? Right here at pi. So my period is pi. You just got to look at the graph and find how long it takes for one cycle. And so my equation, I'm going to call it, let's just call it y equals 5. Now this is a sine, oh, I'm sorry, I'm going to do it down here. It's negative 5. You might not have caught that because it goes down. See, it's at the midline, right? But it goes down first instead of going up first. So that's going to be a negative 5 sine. We need that W value. And then midline is 2, so plus 2. Let's do our W value. W equals 2 pi over the period. And the period is pi. So 2 pi over pi. And, of course, the pi's cancel, and you're left with just 2. So the W value is 2. When W is 2, that gives you a period of pi. That's how they're kind of connected there. So negative 5 sine 2x plus 2. And I know I went fast, and I don't know how much you got out of that, but hopefully at least you got an idea to where we can, again, practice it for the next 2 days. I'll see you in class tomorrow.